right here, this would be 2a and a, 1 and 1. This would be the minus, right? And this would be the plus? Is that right? So I can replace a with, so if we let a equal sine of x, that's what the form would be like. Does everybody agree with that? So 2 sine of x minus 1 times sine of x plus 1. Tristan, are you good with this? Are you with me on this? Or you're good? Jackson, are you with me?
Mm-hmm.
Okay, all right. Everybody, Michaela, you're good? You sure? Okay. Keegan?
How'd you get that?
Okay, so remember that's a quadratic in this form. So if we let a be sine of x, instead of writing it with the sine of x in there, it's like 2a squared plus a, subtract 1. And so it's just going back to the factoring, where you can multiply over the top. So it's 2a squared here and positive a here. So we're looking for factors that multiply to give you this, that add to give you this. Okay? Actually, this would be a negative, sorry, because this times this.
What would that be, 2 then?
So that's 2a times negative a. 2a times negative a is negative 2a squared, and 2a plus negative a is a. Yeah, is positive a, which is what I was trying to get right there. Okay, so
I got 2a squared plus 2a.
2a squared plus 2a plus negative a plus negative 1. Then we factor by grouping, so we factor out a 2a. I kind of skipped that step. So I guess, okay, so a plus 1. And then I factored out a negative 1 here, a plus 1. So you get 2a, subtract 1, times the common factor, a plus 1. So I did go just from here down to here. I didn't show all those steps in between, but that's how you would. Okay? Okay, anybody else? Questions? Okay, so now, Lacey, what do we do from here? Who does know? I wanted to see who knows what to do from here. Cassidy? We're going to use the zero product property because we have 0 equals this times this. So we set each factor equal to 0. So we have 2 sine of x minus 1 equals 0, and sine of x plus 1 equals 0. Okay? Now we continue to solve this for sine of x. So we add 1, and we divide by 2. And over here, we subtract 1. Okay, so that was the easier part. Now we have to come up with all of the solutions. I didn't mean to say it was the easier part. That was harder. I mean, you guys, so much time on factoring in Algebra 1 and Algebra 2. This is just a factoring problem. You guys can do this, okay? It is totally something you guys can do, okay? We haven't factored since Math 111, really. So it was probably good to go through that whole factoring thing, but it's totally something you guys can do. Okay, so now we say we're going to find all of the values where the sine of some angle is equal to a half. So this is where we get to use our unit circle. We get to use our sine curve. We get to use our special right triangles. We get to use so much right now. It's awesome. You have so many tools at your hand right now from all the stuff we've been doing all trimester. So, can somebody, so one of the things you can do is you can take the inverse sine if you want to. So, and that'll give you at least one value. That'll only give you one value. So, what is one angle where the sine of x is equal to a half? Pi over 6, okay? So pi over 6 is one of them. And then because, so x is equal to pi over 6 plus 2 pi n, because the period of the sine function is 2 pi. Okay, groovy? Now, pi over, okay, now the domain, or the other place where we get a positive sign, where we get a sine of some angle as a positive number, is in quadrant 2. The sine is positive in quadrant 2, right? This is a positive 1/2. So we need to have another angle in where we get the sine of that angle is positive 1/2. Okay? So it's like right here and right here. So there's a couple ways to think about it. Here's pi over 6, right? This is pi, so we can go back pi over 6 from, because it's symmetrical. We go back pi over 6 from pi, so here's pi. If I go up pi over 6 this way, what is this angle right here? Okay, so x can equal 5 pi over 6 plus 2 pi n. Okay, good. But we're not done. We have a third of the solutions, probably. We still have this one to deal with. The sine of x, where is the sine function equal to -1?
Negative pi over 2.
Okay, here's +1. Here's -1 is right here. So what is that? Or on the unit circle, where would that happen?
Either 3 pi over 2 or negative pi over 2.
Okay, so 3 pi over 2 plus 2 pi n. Now we have them all. Oops, x is equal.
What about negative pi? Or that's just the same thing?
Yep. So you weren't here yesterday, though, Shayla, when we were talking about that. If you said negative pi over 2 plus 2 pi n instead of this, that's fine. You just give me the starting point and then every 2 pi. So the starting point could actually be pi over 2, 3 pi over 2, 7 pi. You could even say 7 pi over 2 plus 2 pi n. I don't want you to do that because then I have to think more harder. But I would think that hard. If you put that on the test, I would have to figure out if yours is okay. Okay? So, do you guys see how to do this? It's just now getting fun and easy, right? There goes Jackson with his noises back there again. Yes, Zidane.
So the identities, like that one, you kind of like, I mean, Alice had like said something yesterday, but like, are we gonna be having to like memorize those?
The basic ones you will memorize.
Okay.
Now, this unit, we're not gonna do a lot with identities.
Okay.
So right now, I'm introducing you to solving equations, but the next unit, we're gonna spend a lot more time on it. So you're gonna do a little dabbling in it this time,
Okay.
but like on the test, I probably would not put this problem
You
on
wouldn't,
this
okay.
test.
So,
I'll put a more basic one on this test. If you can do this equation, you could do any equation pretty much that I put on the test, but we have one more that we have to do. Yes.
when is the test?
Today's Wednesday, right?
Yeah.
So tomorrow, I'll give the last, assignment. We'll probably review, it's probably gonna be Monday. All right. One more example on solving trig equations.